Hey there, hope you're doing well and good. My name is Shyam, and in this video, we will learn about what is an OSI model, why and how it is used, and its importance in network communication. Firstly, let's look into the agenda for this video. First, we will look into the definition of what is an OSI model. Then, we will look into the seven layers, that is, the physical layer, data link layer, network layer, transport, session, presentation, and finally, the application layer in which we, the users, can interact with. More about this layer in upcoming slides. So, with that, let's start with the first topic, that is, what is an OSI model? Open Systems Interconnection, that is OS full form of OSI model, which is a conceptual model that describes how data is transmitted and received over a network. It is a framework of seven layers, with each with its own specific functions and protocol that work together to ensure reliable and efficient communication between the systems. The OSI model provides a standardized way for different systems to communicate with each other, regardless of their underlying hardware or software. Next is the history of OSI, where it was created by the International Standard Organization for Standardization, that is ISO, in the late 1970s and 1980s. The development of this model was led by the OSI study group, which was formed by the ISO to develop a standardized model for network communication that would enable different computer systems to communicate with each other, regardless of their underlying technologies. The members of the OSI study group consisted of experts from various countries and organizations, including government agencies, universities, and private companies. Here is an overview of OSI model. You have layer numbers along with the name, along with the role of individual layers, along with the protocol that is used in individual layers. And here you have a PDU, where PDU stands for Protocol Data Unit. In simple way, if you want to explain what is a PDU, imagine you're playing a game with your friend, but you're not in the same room. You need to send messages to each other over the internet so that you can play together. A PDU is like a message, but it's kind of a special message that has some extra information in it that helps the computer to understand what it means. So when you send a PDU, you're sending a message that not only has the things that you want to say to your friend, but also tells the computer how to send it and where to send it. So this helps the computer to know what to do with the message so that you and your friend can keep playing the game together. So that's the overview of protocol data unit, that is PDU. But before diving into these layers, there's one thing you need to understand, which comes in every layer, that is protocols. Why do we need protocols in every layer? That is because protocols are used in OSI model to define the rules and procedures for communication between devices on a network. These protocols provide a standardized way for devices to exchange information, ensuring compatibility between different types of devices and software from various manufacturers. Each layer of the OSI model relies on one or more protocols to communicate with the corresponding layer on another device. By using protocols, OSI model promotes interoperability and helps to ensure efficient and reliable communication between devices in a network. In simple terms, protocols are a set of standardized rules and procedures that define how the data is transmitted and received between the devices. So with that, let's start with the first layer, that is the physical layer. Physical layer is the first layer in the OSI model, and it is responsible for transmitting raw data between devices. This layer actually defines the electrical, mechanical, and procedural specifications for transmitting data over the network. The primary function of this layer is to convert digital data into format that can be transmitted over a network. This layer deals with the physical aspects of a network communication, such as voltage levels, signal timing, and physical transmission media like cables. Physical layer devices include network interface cards, that is NIC cards, NICs, repeaters, and hubs. The physical layer is also responsible for ensuring that the data is transmitted with the minimum errors. and without the loss of data. It also handles flow control, which regulates the pace at which the data is transmitted so that the receiver can process it properly. And also it is this layer is independent of the underlying technology, so that it can work with the different types of media such as copper, fiber optic, or wireless. There are protocols that are used in this layer. One is USB, that is Universal Serial Bus, which is a protocol that is used for connecting devices to a computer and commonly used for data transfer and charging. Next one is Ethernet, widely used protocol for wired local area networks that uses various physical layer standards for transmitting data. Next one is RS-232, a serial communication protocol commonly used for transmitting data between computers. And ATM, asynchronous transfer mode, a protocol that is used for transferring data over high-speed networks. The next layer is data link layer. The data link layer is the second layer in the OSI model, and it is responsible for providing error-free transfer of data between the nodes of the network. This layer is also responsible for framing the data and adding necessary addressing and control information to the data packets. It also handles flow control and error detection and correction to ensure that data is transmitted accurately and efficiently. The data link layer is divided into two sublayers. One is the logical link control layer and media access control layer. The LLC sublayer provides flow control and error checking functions that are independent of the physical media used for data transmission, whereas MAC sublayer is responsible for controlling access to physical media and managing data transmission between nodes on a network. The data link layer devices include switches, bridges, and all. And this layer is responsible for providing a reliable and efficient way to transmit data over a network. And it is critical for the proper functioning of the network. This layer provides addressing and framing mechanisms that allow data to be transmitted over the different types of physical media such as Ethernet and Wi-Fi. This layer uses MAC address to uniquely identify each node on the network. It also includes mechanisms such as for detecting and correcting errors that may occur during the data transmission over the network. There are protocols that are used in this layer. First one is which is very important one. Carrier sense multiple access with collision detection CSMA/CD, which is a protocol used in Ethernet LANs to detect and manage collisions that occur during data transmission when multiple devices try to send the data at the same time. And next one is a point-to-point protocol, which is a protocol that is used for establishing and maintaining a direct connection between the two nodes in a network. Next layer is network layer. The network layer manages communication between the devices on a network. It uses logical addressing such as IP addresses to identify devices and determine the best path for data to travel between them. This layer creates and manages the packets of data, which are units of information over the network. The network layer also provides error detection and recovery mechanisms to ensure that data transmitted is accurate and reliable. It is also responsible for routing data between different networks, and this layer prevents network congestion by controlling the flow of the data. It also manages transmission of data across the network, ensuring that each packet of the data arrives at its destination in its correct order. The network layer can also perform fragmentation, which breaks larger packets into smaller packets for easier transmission over the network, and it can also perform reassembly, which combines small packets into larger ones at the receiving end. Also, this layer is very important in the OSI model, as many networking protocols operate in this layer, where the protocols such as IP, that is Internet Protocol, which is a primary protocol, used for transferring data across the internet, which is responsible for addressing and routing packets between network nodes. Next protocol is ICMP, that is Internet Control Message Protocol, which is used by IP to report any errors and provide any diagnostic information about any network issues that occur. And next protocol is the Address Resolution Protocol, which is a protocol used to map IP addresses to physical addresses in a local network. Next layer is transport layer, which is responsible for reliable and efficient delivery of data between devices on a network. It uses protocols such as TCP and UDP to manage the transmission of data. TCP provides reliable, ordered, and error-checked delivery of data, while UDP provides unreliable, unordered, and unchecked delivery of data. The transport layer segments the data received from the application layer into manageable chunks called as segments. And these each segments is assigned with with a sequence number in which it is used to ensure that segments are received in the correct order. It uses a sliding window protocol where it is to control the amount of data that is sent before waiting for an acknowledgement from the receiver. This layer also provides error detection and recovery mechanisms such as checksums and retransmission of lost or corrupted data. This layer can also perform congestion control to prevent network congestion and ensure efficient use of network resources. There are many popular applications such as web browsers, email clients, and file transfer protocols rely on the transport layer to ensure reliable and efficient data transmission. There are protocols that are used in this layer. First two we have discussed, that is TCP and UDP. Next one is Datagram Transport Layer Security, which is a connection-oriented protocol that provides a secure transmission of data packets between the applications. Next one is Reliable User Datagram Protocol (RUDP), which is a connectionless protocol that provides reliable delivery of data packets between the applications. Next one is Session Layer, where the session layer is responsible for establishing, managing, and terminating sessions between applications on different devices. It also provides services such as authentication, authorization, and encryption to ensure that secure communication takes place between the applications. Session layer also manages dialogue between the applications by coordinating communication between them. It establish some it This layer establishes something called as checkpoints during the transmission of data or during a session to allow for recovery or in case if there is any interruption or failure during the transmission of the data. The session layer also manages the flow of data between applications by providing mechanisms for starting, stopping, and resuming data transfer. This layer can also be used for remote procedure calls, which allow applications on different devices to communicate with each other as if they were on the same device. There are protocols that are used in this layer. One is RPC, which is a protocol that allows client process to call a procedure on a remote server process and receive the results. Next one is Session Initiation Protocol, which is a protocol used to establish and control multimedia sessions such as voice and video calls over IP networks. Next one is Network File System, which is a protocol that is used to allow remote file access and sharing over a network. Next one is a Simple Network Management Protocol, which is a protocol used to manage and monitor network devices and their performance. Next is presentation layer, in which this layer is responsible for formatting and representation of the data that is to be transmitted over the network. It also ensures that data is presented in a format that can be understood by the receiving application, regardless of the underlying hardware or software used. Presentation layer can also handle tasks such as data compression, decompression, encryption, decryption, encoding and decoding schemes and all like that. It can also perform or provide formatting and conversion services such as multimedia data such as images, audio, and video. There are protocols that are used in this layer. One is encryption protocols such as SSL and TLS, which is used to secure data transmission over a network by encrypting the data. Next one is the compression protocols such as zip, gzip, and all. Then next is ASCII, which is a protocol that is used for encoding and decoding the text data. The final layer, that is application layer, where the application layer is the highest layer in the OSI model and responsible for providing network services to end users. It also provides an interface that it is between the user and the network, which enables the users to access network resources and application. This application layer provides services such as file transfer, email, remote login, and other network-based applications. It also provides protocols for handling different types of data such as text, graphics, and multimedia. This layer interacts directly with the user and also provides a user-friendly interface for accessing network resources and services. There are protocols that are used, commonly known as one is HTTP, which is a protocol used for transferring data over the World Wide Web, which allows clients to request web pages from web servers. Next one is SMTP, which is a protocol used for sending email messages over the internet. Next one is the domain name system, which is a protocol used for translating domain names into IP addresses. And last protocol is simple network management protocol, which is a protocol used to manage managing and monitoring network devices and their performance, which allows network administrators to gather information about the network devices and manage them remotely. We have so many layers in this OSI model. Why do we have so many layers? It's because it was designed to create something called as a standard for computer networks to ensure that devices and systems from different manufacturers could communicate. And the layered approach would allow for easier development and maintenance of the network with the greater flexibility and scalability. There are two types of addresses that we have come across through. One is IP address and another one is MAC address. Why do we have these two types of address? Is because where IP address is like a phone number or a street address for devices connected to the internet. For example, if you want to send a message to someone, you need to know their phone number. A MAC address is like a name or a tag for a device on a local network. Say, for example, if you're at the party, you want to talk to someone, you need to know their name to recognize their face. So that's the difference between MAC address and IP address. IP address is like street address, and MAC address is like your home address. So that's the difference between these two addresses. To conclude this video, we will summarize what we have discussed. OSI model is a conceptual framework for understanding how data flows through a network. It consists of seven layers, each with its own specific set of functions and protocols, where physical layer is responsible for transmission of raw bit streams of data, where next layer, data link layer, is responsible for error detection and correction, and network layer is responsible for routing data packets between different networks. Transport layer is responsible for reliable end-to-end data delivery, whereas the session, presentation, and application layers are responsible for managing application level protocols, providing data formatting, and enabling communication between applications on different hosts. And if you find any difficulty in remembering these seven layers, there is a shortcut which is on this slide, which you can remember easily. Is that please do not tell secret passwords anytime. So this is one easy trick that I have mentioned, which might be helpful for you to remember. And that's it. That's the end of this video. Hope you have learned something about the OSI model basics. Hope you have understood the roles of each layers, what are the protocols that are used, the importance of protocols, and all like that. So that's it. Keep learning and have a good day. And thank you.